So thank you everyone for coming today. As a member of PAST myself, these webinars are extremely useful, and it's very important for the community that we get involved. And I can't emphasize Jason's point enough that if you're interested in presenting or advancing your career, this is a great way to do it. So please, if you're interested in presenting, get on that. Like we said before, my name is Brad Llewellyn. I'm a data scientist for a Microsoft consultancy called Llewellyn. And my job revolves around helping individuals and organizations kind of unravel what data science is and how they can use it to get from where they are to where they really want to be. So the purpose of this talk today is we're going to walk through one of Microsoft's more interesting data science tools called Azure Machine Learning Studio. There is a version 2 of this called Azure Machine Learning Workbench that is not the function of this talk. Today we're going to be talking about the version 1, which is the Studio, which is what's in the web GUI. And we'll see that here in a few minutes. So a little bit about me. I have the alphabet soup of certifications that most people do. I've been an analytics consultant for about 5 years now, and I've been at my current employer for just about 2. If you like what you hear today and you want to learn more about Azure Machine Learning Studio, I blog pretty regularly at breaking-bi.blogspot.com. You can also find me at Twitter at breaking.bi, and I have my LinkedIn there as well, which is just my name. A tiny smidgen about who I work for. Llewellyn is a full-stack Microsoft consultancy, meaning that we offer app dev, software dev, project management, data work for organizations. I'm on the data team, specifically on the data science side. So I work with customers every day about their data science needs. Again, just another shout out to the PAST group. I'm a huge fan of PAST and can't emphasize enough how important it is to get involved. Now, moving on to why we're all here today. Our agenda today is going to be very demo heavy. We're going to start with a little intro to what is Microsoft Azure for those who might not be super familiar. Also, we're going to talk about why you would want to use Azure Machine Learning as opposed to some of the other tools out there like R, or Python, or SAS. And then we're going to get to a lot of demo. So let's start with what is Microsoft Azure. Microsoft Azure is Microsoft's managed cloud. So anything we build on premises, Microsoft will offer to build it for us, and all we have to do is pay them a fee. And that gives us a tremendous amount of flexibility in that we don't have to worry about managing any infrastructure anymore. We don't have to worry about buying hardware. We don't have to worry about buying anything except the computer you use to connect. So when we want a new SQL server, we just click a button, a new SQL server is created. That's the big advantage of the cloud. In the data science world, depending on what organization you're in, there are a lot of organizations that feel the cloud isn't really ready for enterprises. My data needs too much security. My performance needs are too high end. The vast majority of that is simply not true anymore. So if you're in one of those organizations that is considering moving to the cloud or hasn't quite moved to the cloud yet, I highly recommend you seriously start entertaining the thought of moving to the cloud, as that's where the future of data is, and especially the future of data science. What can we build with Azure? At this point, literally anything you'd ever have on premises, including things you would never have on premises. So virtually anything your organization has, you can build out there. I have seen very successful customers who are what's called cloud first, cloud only, meaning they have zero physical infrastructure. Everything they do is out in Azure, so they don't have to have giant teams of people that do nothing but manage infrastructure. Moving on to the meat of the topic here. What is Azure Machine Learning and why should we use it? Throughout my career, I've come across a number of different struggles within the data science industry. I read an article on LinkedIn a few weeks ago that said 80% of all data science teams are failing to provide value within their organizations. There are a lot of reasons for that, and we're going to try to develop an easier method here, a way where failure isn't the expectation, where success is the expectation, and failure is the rare occurrence. That's some of the value I feel that Azure Machine Learning really brings to the industry. So what are these struggles? Why are some of these teams not providing value for their organizations? First of all, a lot of the existing tools. I love R, I love Python, I love SAS. They are hard to learn. They are very code heavy. And even to get started, you have to learn a brand new coding language that's likely not similar to any other coding language you've already learned, unless you're already a functional programmer today. That obviously makes it very difficult to hire people. It makes it expensive to hire people. It makes it difficult for interested individuals to move into data science. And it's really the next big roadblock that the data science industry is working through. And I think Azure Machine Learning is one of the best tools to get by that. Next, anytime you're working with code-heavy tools or tools with steep learning curves, testing and optimization becomes really time-consuming. Anytime you code something, you have to test it. And as I'm sure we're all aware, working at larger organizations, a lot of times that just testing and optimization doesn't take place. You say, it's too hard, we're just not going to do it, we don't have time, things go out to production without having been tested. It happens, and it becomes a serious problem in a lot of organizations. So anything we can do to lessen how much time that takes or eliminate it entirely would be extremely beneficial to most organizations. Also, a lot of the existing tools require a really heavy knowledge of statistical techniques. When you want to build a machine learning model in R or Python or SAS or Minitab or whatever your tool is, you're going to give it a data set and then you're just going to be stuck. The next question is going to be, well, should I use linear regression? Should it be logistic regression? Should it be a decision tree or k-means clustering? I don't know what to use. You have to have this great background of knowledge to even get started. And that's one of the things we're going to talk about today that Azure Machine Learning helps out with. And finally, depending on what side of the space you're in and which tools you use, productionalization can become a very difficult task. I have heard of organizations having to buy or use open source third-party tools just to productionalize their R code. SQL Server has made huge bounds in this area over the past couple of years, integrating R and Python directly into SQL Server. Even then, that doesn't cover the entire space. There are customers that don't own SQL Server. There are customers who are still on an Azure SQL, which in most regions doesn't support R or Python right now. So that's not always an option. So a way we could productionalize our existing code, move this stuff to be able to use by our business, would have tremendous value. So now that we've talked about those main struggles, how does Azure Machine Learning fix those? How does it get around them? First and foremost, Azure Machine Learning is a cloud resource. We won't spin anything up today. No physical infrastructure. Nothing's taking place on my machine. This is all out on the web. All I do is log in and I can access it. On top of that, it scales dynamically based on my needs, meaning if I give it a small data set and I'm not trying to do anything very complicated, I don't get much resources. It finishes quickly. Nobody complains. However, if I have a really large data set, 1 million rows, 10 million, 100 million rows, trying to do a complex analysis on that, it will recognize that I need a lot of resources, and then it will give me as much as I need to complete it in a reasonable amount of time. Also, if anybody's gone out and looked at the Azure Machine Learning documentation on Microsoft Docs or MSDN, it is spectacular. It is some of the best documentation I've ever seen in my life, to the point where I regularly use it when I need to know exactly how a module works, or if I need to know what something does or access to which parameters do what. It's a great place to go. I have never left there not understanding what I came to learn. Another great value is it's a completely code-free GUI. I'm not going to code anything today. There is the ability to put R, Python, or SQL code directly into Azure Machine Learning, and I have a more advanced talk in a few weeks where we'll go over that. But today, no code at all. For someone to get started, you don't have to learn any new languages. It's a completely drag-and-drop interface. And finally, it easily integrates into any enterprise data structure using what are called APIs. So we publish the API out to Azure, and then any web app or any SQL database or anything can hit that using the same old tools that always hit APIs. So it's globally accessible no matter what platform you're trying to use it from. So with that little tidbit, let's get into a demo and see how it actually works. Hop over to whatever your favorite search engine is. We can search for Azure Machine Learning. Get past the ads and machine learning will come on. First link. We see Microsoft's nice intro page. All you have to do is click Get Started Now. First thing that pops up here is pricing model. Nice big green box in the middle. Tells us everything we need to know. For somebody to get started, you can get a fully functional Azure Machine Learning workspace for absolutely nothing. You don't even have to supply a credit card. All you do is give them an email address and off you go. So there is no reason that we all can't go home tonight and spin up an Azure Machine Learning workspace and start doing data science. For those of us that want to use it in a more enterprise fashion, we have larger data. We want to have parallel processing on things. We can pay for a workspace, but even when we're paying for the workspace, it's only $10 per user per month, putting it around the same level as Power BI, meaning that it is very cheap. I have never seen a customer ever look at Azure Machine Learning and go, this is too expensive for me. Never once. I've heard that argument a number of times about most other data science tools. Another advantage of the enterprise workspace is you do get support. So you can use your Azure subscription and reach out to Azure support if you're having issues or want to know something, and they can help you. So I'm not going to click sign in here. I've already got a workspace open. So we will hop over to my other browser. And this is Azure Machine Learning Studio. The main workhorse of Azure Machine Learning Studio, as we see here, is what's called an experiment. An experiment is, as we can see on the right side of the screen here, is what you think of as a data flow in SSIS. It's data comes in, we do something to it, and something comes out. So this is going to be most of what you'll work with when you're working with Azure Machine Learning Studio. We also have a few other options over here. We can access our web services over here on the left side of the window. I don't have any web services right now that we can utilize, but when you do create them, this is where they would pop up. We also have what's called notebooks, which we won't get into here, but if you've heard of Zeppelin notebooks, this is the same thing. We can also store data sets directly in Azure Machine Learning, and we'll get to in a couple minutes why you'd want to do that. Also, any of our trained models we can store here as well. So later on in the presentation, we'll create a trained model, and we'll talk about why you'd want to store that in Azure Machine Learning. So how do we get started? We want to make some sort of experiment, but we're not quite sure what we want to do. Up at the top of the experiments window here, there's a button called Samples. We click on this button, and we can see Microsoft already provides us with, 40 or 50 odd experiments that do just about anything we regularly want to do. So if I come out here and I'm interested in clustering, I can just search for clustering, and I can see that I've got 4 different experiments here that Microsoft's already built for me to show me how to do clustering. So when I was learning Azure Machine Learning, this is exactly what I did. I would just pull up a couple interesting samples, and I would click through them and see, what are they doing here? What does each of these do? And as we go through the demo, you'll see more and more about how to interact with this interface. Also, if you're interested in learning more, but Microsoft's provided samples don't go really as far as you'd want to go or don't touch on a topic you're interested in, you can go out to something called the Cortana Intelligence Gallery. You can just search through that. Out here, we have 2 sections. We have experiments and machine learning APIs. If we look at experiments, these are exactly what we were looking at in the Azure Machine Learning Studio. The difference being, these aren't created by Microsoft. These are created by community members just like you. So people create an interesting experiment, say natural language processing. I really want to be able to take Facebook messages and get sentiment analysis out of them. People will build those experiments, and they'll publish them up here to the Cortana Intelligence Gallery so that everybody else can download them. I have from time to time been approached by a client with a problem I don't know how to solve, something I've never done before, maybe even using techniques I've never even heard of. And I can go out to the Cortana Intelligence Gallery and I can search for those, and I can use that to solve the problem I needed to solve. If we're not interested in building our own experiment, if we'd like something that's really already built for us, there's a section here called Machine Learning APIs. This is also known as cognitive services. Out here, you'll find a lot of APIs built by Microsoft using Microsoft's team and Microsoft's data to really build these comprehensive data science models. So for instance, we have the Face API here. That's a very common one. You can feed the Face API a picture, and it will automatically point out all of the faces in the picture. So you can use it for image recognition, and you don't have to build any of that. You just call the API. So no matter what your data science needs are, the whole goal of this talk is to make it easier for you, to remove that barrier of entry so everybody here can get started. Now that we've talked about everything else, let's build an experiment. Let's see how easy it is. We've talked about how easy it is to use this. Let's see it in action. The first step of any experiment is going to be getting data somehow. So we have to get data into Azure Machine Learning. There are two ways we can do that. First, we can go to Datasets. Down in Datasets, we can click this New button at the bottom, and then from Local File. And here we can see we have a few different file types we can read. Mainly these are going to be text files. So I will often use this for fast prototyping if I just need to get a data set out of existing infrastructure and into Azure Machine Learning. I will often just use a CSV to do it. It's also useful in cases where I've encountered customers that do not want to connect their on-premises environment to Azure for whatever security reason they may have. So we build these approved data sets, and then we export them using CSVs, and we upload the CSV to Azure Machine Learning directly. That can be very helpful for skirting around security policies and things like that. We also have the option down here at the bottom of importing zip files or R objects. This is really helpful if we're using custom R or Python code directly in Azure Machine Learning. We can import our existing libraries. So if we're using specific Python or R libraries to do our analysis, we can import those directly here. Okay. The second option is in the experiment, so we'll make a new experiment, just a blank one. A quick overview of what this canvas does. In the middle here, we have the canvas, and this is where you'll drag and drop everything. This is where you'll do your actual interacting. On the left side, we've got the modules, which is the things we'll be dragging and dropping. And on the right side, we have the properties. This is where we'll be interacting with the individual modules. And we'll see that in a minute as well. So let's look at a tool called Import Data and a tool called Export Data. This is how you would get data in and out of Azure Machine Learning in general. So Import Data, as we see on the right side, gives us a few different options for the types of data we can bring in. First and foremost, we have SQL. We can access Azure SQL database directly. We can also access our on-premises SQL databases if we'd like. To do that, we need what's called a Microsoft Data Management Gateway, the same type of gateway you'd use for Azure Data Factory or Power BI. If we're using big data, we can connect to an HD Insight cluster using a Hive query. We can connect to Azure Document DB, which is now called Azure Cosmos DB. Or we can connect to Azure Blob Storage or Azure Tables directly. Finally, if we want to use publicly accessible data, which is really helpful for prototypes or demonstrations, we can connect to web URLs using HTTP. I've also seen this integrated for some organizations that expose their data via HTTP. It's obviously not secure, but if your data is not sensitive, it's not a big concern. And finally, we have a data feed provider for anybody that might be outside that realm, but you need to be able to connect to a more obscure data source. You can do it there. As far as export data goes, our options are limited to Azure. We can only export data out to Azure sources. However, the export data module itself isn't used very frequently. The reasoning behind that is this isn't like SSIS where our job is to pull data in and then ship data out to somewhere else. We're building models and then we want to productionalize those models. So that's a different process that we'll see at the end. I use the export data module from time to time if I'm dealing with very large data sets and I'd like to export them out to SQL for additional analysis. I can do it like that. But the majority of the time, I just import data and do my analysis directly in Azure Machine Learning. So now that we've talked about how we get data in and out, let's look at our actual data set. If I go up to Save Data Sets, we have a bunch of samples. Microsoft provides these for us. The first one here is what's called the Adult Census Income Binary Classification Dataset. What this is this is a data set containing one record per individual with a bunch of demographic information about that person. So it's their age, their race, their employment industry, and those sorts of things. And our goal is to predict income based on all those factors. So if we right-click on the module, we see a output here labeled 1. We can visualize that. You can do this for any module in all of Azure Machine Learning, well, almost any module that has an output. And the visualization differs based on what you're visualizing. In this case, we're visualizing a data set, so it shows us a data set. We can see that our data set has about 32,000 rows and 15 columns. If we scroll across, we can see which columns we have: age, work class, education, marital status, all of that. We could look through this data. It shows us a sample, so it'll show us about the first 100 or so rows and the first maybe 30 columns. So we're not seeing our entire data set in here. But it does give us a few ways to interact with that. One, these histograms on the top of every column, we can scroll across those really quickly and say, oh, race is skewed. I click on race, out pops the statistics. It shows me there's 5 unique values, 0 missing values, which would be important for more advanced analyses. It tells me what type it is. It's just a string. And we can see the histogram up close and see what the different values are. So we hover over the first bar and we see white makes up about 85% of this data set. Black makes up 9.6%, and it goes down from there. We can see exactly what's in our entire data set without having to write a whole bunch of complex SQL statements or R code. So it gives us a really quick overview of what's going on. For our numeric features, we have a button over here where we can view as box plots. So we could view that as a box plot, and we could see age, and okay, there's one outlier in this data set. Somebody's age 90. That obviously doesn't have any impact on string features because you can't make a box plot out of a string. But let's move over to the column we're really interested in. At the very end of this data set, there's this column called income. What we want to do is imagine we run a website. And users log into that website and they provide us these 14 columns that aren't income. So they provide us their age and their marital status and their occupation and whatnot. And we want to be able to predict how much money they make so that we can know whether to sell them an inexpensive product or sell them a more high quality product. In that case, we're interested in how much they make. Fortunately, we've actually gotten a little bit easier problem here. Instead of knowing exactly how much they make, you make $97,142.37 a year. Instead of that, we only care, do you make less than or equal to $50,000 or more than $50,000? That's all our site needs to know in order to know whether to pitch you product A or product B. So our goal is to build a machine learning model that we can use to predict this income value when we don't know it. So how do we do that? Azure Machine Learning, I say, makes it really easy. So now that we've looked at our data and we know exactly what we want to do, let's build a machine learning model. If we expand the machine learning section of the modules pane on the left side, we see a section called Initialize Model. We click on that, and it gives us 4 options. This is where Azure Machine Learning really makes it easy on us. Instead of it being coding and we having free reign to type in literally anything we'd ever want to, it gives us options. It says just choose. So here we have anomaly detection, which is this unusual? Very good for fraud detection. Not very good for our problem right now. We have classification, which means is it A, B, C, or D? It's pretty similar to what we have. We only have A or B. Is it clustering? Clustering is when you don't want to ask a particular question, but you just say, look through my data and tell me what's going on here. I think there are 6 types of people in this data set. Can you identify what those 6 types are? And then it'll go through and build 6 different clusters for you and tell you about your customers. Finally, we have regression. Regression is when we're trying to predict a strict numeric value. So if we were trying to predict exactly how much money they made, that would be a regression problem. Regression is generally more difficult than classification. So fortunately for us, we only have to choose is it A or B. So that's classification. Once we look at classification, we have 2 main options here. We have multi-class algorithms, which would be if you had A, B, C, or D, if you had multiple options. In our case, we only have 2 options, so we're in 2 class. So now we've gone through our problem and we found, hey, there's 9 algorithms here that we could use. In a production use case, I would generally test all of these. It's actually not very difficult to drag them all out and connect them all. So I actually did that this morning for a customer. For our case, we're just going to pick one. We're only interested in a show of functionality. So we'll just pick one. I'm choosing Boosted Decision Tree for 2 reasons. One, there's a website called Kaggle.com. If you're interested in getting started in data science or learning more about data science, it's a great place to go. It is a competition website where individuals will log on to the website and find what are called competitions out there. So an organization like Netflix did this, will post a data set and say, solve this problem for us. Netflix famously offered $1 million to anybody that could build a better machine learning algorithm than they use internally. It didn't actually end up working, and I don't think they ever ended up paying anybody. But what it did do is it garners a lot of people that go out, some amateurs, just like us, some super high-end professionals, best of the best, what they call grandmasters. So you'll be able to look through what everybody else in the community does to solve a problem. And 2-class boosted decision tree is far and away the most common winner of those sorts of competitions, just because it's easy to use, it's fast, and it's very powerful. So if I had to choose one algorithm, it's almost always boosted decision tree. It also provides a fun little visual we'll see here in a minute, so that's nice too. Once we have our data and our model, we need to do what's called training. So there's a module here called train model. This model we see up here on the right side. This model is what's called untrained. It's an empty math formula. It's got good bones, but there's no muscle, there's no meat on it. In order to do that, we have to combine them. So we click on the output of our data set, and then we need to drag it to connect to the train model. When in doubt, it goes to green. If there were more than one green, we could always hover over the inputs, and it tells us what it wants. It wants a data set. It wants an untrained model. This provides a data set. This provides an untrained model, so we can see easily where things need to go. Once we've connected them, we need to just supply what's called a label. The label is what we're trying to predict. So in this case, we want to predict income. So we use the selector, and we click the run button, and off we go. This is going to take a couple of seconds to spin up. This is a small data set, and it's already cached, so it's going to run virtually instantly. We could visualize our untrained model. It's not going to be very helpful. In fact, I don't even know what it would show. Our trained model, though, has a bit more of an interesting visualization. So a boosted decision tree is basically a set of decision trees. So if we zoom in here, scroll up to the top, we can see how a decision tree works. So we click on this top node. These are called nodes. Each node is a decision. It says, I want part of my data set to go one direction and part of my data set to go the other direction. It's going to split your data set into 2 pieces based on the rows. So they're all going to have all the same columns, but it's going to break it into 2 different sets of rows, similar to a filter. Over on the right side, we can see the predicate. That's what it's using to make its decision. So in this case, it's using a column called marital status.married civ spouse. If you were very keen-eyed in our initial visualization, you probably didn't see this variable. Marital status itself was actually a string feature. It had a value of married civ spouse for some rows, but it also had values of divorced and other things. Most machine learning models, most data science algorithms don't like strings. They want numbers for absolutely everything. So Azure Machine Learning, wanting to get us from point A to point B as quickly as possible, it will do most of the work for us. So it took our marital status column and it broke it out into 6 or so different columns based on how many unique values there were. And one of those columns is married civ spouse. So what this column means is if this particular record, if this particular person had a marital status of married civ spouse, then this column takes a value of 1. If they have any other marital status, it's 0. And then it does that for every unique value of marital status. That technique is called indicator variables or dummy variables. Python calls it one-hop processing. It's the industry standard way of turning string features into numbers. So this predicate now, we can read it as, is this married civ spouse less than 0.5? Since it only takes a 0 or a 1, we can interpret that as meaning 0. If marital status married civ spouse is 0, it means they are not married. So this true branch takes all the not married people, and this false branch takes all the yes married people. And it keeps doing that over and over again until it reaches one of these, what are called leaves. And when you reach a leaf, Azure Machine Learning decides, I don't want to split you anymore, I'm just going to make a prediction here. And that's how decision trees work. So we've got this model, we've built it, it looks fun. How do we know if it's good? How do we know if this is something that we'd want to show to the rest of the business? In order to do that, we have another technique called score model. So scoring takes a trained model and applies it to a data set. So the purpose of this is to find out how good our model would be at predicting the income of a new person, somebody it hasn't seen before. So new person logs into our website, what's their income? I've trained this model using the entire data set. So if I was to score that same data set, I'm effectively cheating because I'm not asking the model to predict values it hasn't seen. I'm asking to predict values it has seen. So it should be better at that than it should be overestimating its value at that point. So a very common way we get past this is something called splitting. There's a module for that. We go split data. We just split our data set into 2 pieces. We've told it we just want a randomized split, meaning I don't care which records go which way, just randomize it. And we get to choose what percentage we want to go one way or another. You could have people argue until the end of time about what the optimal split percentage is. I generally just go 70-30. That means 70% of the data is used to train the model and 30% is used to test the model. You could certainly use 60-40 or 50-50. I've seen people do those with no issues. So we split our data in 2 sets and we send part of it to the train and part of it to the score. Now let's run that and see what happens. As you can see, it's very easy to just drag and drop things onto the interface and get moving. There's no need for looking up code, no need for checking syntax, no need for testing or optimizing any of this. It just always works, which is how it makes data science so much easier. So now that we have split our data, let's take a look at the 2 outputs here. Notice we can visualize each of them individually. So we visualize our split. Notice we've got the same 15 columns, but only about 23,000 rows. That's about 70%. About 70% of the data set went into the train, and the other 30% went down to the score. So if we visualize that, we can see we have about 10,000 rows here, about 30% of our data set, but 17 columns. Something's changed. So we scroll to the end, and we see the score module has added these 2 new columns to the end, scored labels and scored probabilities. This is what we're going to use to test our model. The question here is, we have predicted this value in the scored label, but we know the actual value. So we can look at this and say, how often is this model right? How often is it wrong? To be technically correct, these machine learning models don't predict values, they predict probabilities. So the scored probability is what's actually been predicted by the decision tree. What this scored label has done is it simply said if the probability is less than 0.5, it goes one direction. If it's greater than 0.5, it goes the other direction. So in practice, I generally work more with the scored probabilities than I do with the scored labels. It gives me more flexibility to do more advanced analysis. But for our case, let's just use the scored labels. So we can look through this. We can say, okay, it seems to be right most of the time. It's wrong right here. It's missing a value right here. How do I interpret this? How do I know if this model is good or not? We have another module for that. The module is called Evaluate Model. Drag that out. Give ourselves a little room. Evaluate Model wants scored data sets. It can take 2, actually, because we could evaluate 2 models at the same time. But we connect it, and we run. In our case, we're only interested in evaluating the 1 model. So we run that. It puts these little clocks beside everything showing that it's running, but actually because I've run all this before, all of this is cached. Notice how it just runs instantly. Things don't take time to run. That's because I'm using a saved data set and everything's cached, so I don't have to rerun everything every time. That's a big advantage of using a saved data set. If you're querying a SQL server or something like that, Azure Machine Learning doesn't really know whether the data's changed or not, so it reruns it every time. That's just something to keep in mind if you're building a large experiment using a live data source, that you might want to save intermediate data sets from time to time so you don't have to rerun a long section of code over and over again. Now that it's done running, we can visualize the evaluate model. And we have a pretty little curve here. Up at the top, we can see this is called a rock curve. It's the most famous curve for evaluating classification models. Basically, the better your model is, the more it goes to the top left of the screen. A flip of a coin would be this line here in the middle, the 50-50 line. So our model is significantly better than 50-50, but we'd expect it to be. It'd be worthless if it was 50-50. We have some other curves here. Precision recall curve, which instead of going to the top left, goes to the top right, and lift. These are useful for other types of situations. Not every situation is meant for a rock curve, but that's a more complex talk that we could have at a later time. If we scroll down, we see we have a bunch of basic metrics here. We have number of true positives and false positives, and that's what's called a confusion matrix. It's the number of times that the model was right or wrong. So how many times was the actual value positive? In our case, positive means greater than 50K and negative means less than or equal to 50K. So how many times did it correctly predict greater than 50K? 1,500. How many times did it correctly predict less than or equal to 50K? And then these are the number of times it was wrong. We can combine these to get a little bit more of an understandable metric, accuracy being the most common one. Basically, accuracy is the number of times it was right, divided by the total number of times it predicted. So it's 86% of the time it's right. It's not up for us to decide right now whether or not that's good enough. Ordinarily, we would have some sort of existing business process or some ability to tie money to it. So we can say, is this good enough? Does this make us money? Does this lose us money? Does this improve on our existing process? We'd be able to tell that because we would have baseline metrics. In our case, accuracy is a perfectly fine metric to use. So we also have other metrics like precision, recall, and F1, as well as a metric called AUC. Those are for more advanced use cases, and we could certainly get into those. For a start, accuracy is a perfectly fine metric to use. So let's say 86% is good enough for us. We didn't have an existing process. 86% is great. It's much better than the nothing we knew before. So let's get this in production. As you've seen, it took me, minus all the talking, maybe 2 minutes to build this. So it's very, very fast. Let's get it in production. At the bottom of the screen, we have this Setup Web Service button. We could set up a retraining web service, and this is where we get into trained models. We'll talk about that here in a second. In our case, we want predictive web service. So we click predictive web service. It does some fancy footwork, moving things around. So what this did was it noticed we had one trained model in our experiment. So it took that trained model and it saved it. Remember we had that section of saved models out in the workspace? This is so that every time we call this API, every time we call this web service, it doesn't have to retrain the model. The trained model is already saved. You just ship it up a data point and it ships you back a prediction. Person logs in and you say, I need to know right now how much this person makes. It goes, okay, predicts it and sends it back to you. It kept the score model because that's very important because we don't want to output the trained model. We wouldn't know what to do with that. We want to output that prediction. And it also dropped in web service inputs and web service outputs so that it knows where data needs to go. So we need to run this one more time because it's technically a new experiment. So we have to run it to cache the metadata. It should also be relatively quick. So our goal now that we have built a predictive experiment, we want to deploy this out to Azure so that other people in our organization can use it. People say, oh, I really want to use your 86% accurate model. How do I use it? We click this Deploy Web Service button. We want to deploy new. There's still some existing legacy out there called the Azure Classic portal. In general, you don't want to use that. You want to use new for everything, also known as the Azure Resource Manager. We could give our web service a name. So we could call it 2017-1207 Azure ML Demo, whatever you want to call yours. We provided a storage account. If you're using the free workspace, it just gives you a storage account. If you're paying for one, you assign it a storage account based on your Azure subscription. We also need to give it a price plan. If you have the free version, it gives you what's called a dev test price plan, which is free. It doesn't cost you anything, but it does limit the amount of times you can hit it every month. For me, Microsoft's nice enough to give me a short budget for my own plan, so I get a paid one, and I click deploy. It doesn't like that name. It might not like the spaces. Let's take the spaces out. That seems to be working now. So what it's doing now is it's taking our experiment we just created in the studio and it's deploying it out to Azure for us in literally a couple of clicks. I don't know how to deploy web services. I don't even know how to run web services. But Azure's taking care of all the work for me because my job just needs to be dealing with the data. So now that we've deployed it, we're still stuck with, I've got a web service, but honestly, I don't know how to use it. I don't know how to call a web service. It's too much development work for me. So there's this tab over here in the web services URI. You can find this at services.azureml.net. We click consume. It shows us some dev speak here. It's got primary keys and secondary keys and request response URIs and batch request URIs. What I really like about this page is if we up at the top here, we have the ability to export this to Excel. So I could open this in Excel, and within a couple of clicks, it connects to my Azure Machine Learning Workspace, and I can test my predictive model directly from Excel. I've seen use cases where that's very helpful. In fact, I worked with a team at a local hackathon building something like that, which was interesting. That's very good for testing or for small use cases. If you want to put this into production for your organization, we scroll down, and we see that it gives us C#, Python, and R code that will actually run our machine learning API for us. So I don't have to know how to code C#. I can just give this link to one of our developers, and they'll easily be able to use this and turn it into a call. They put in the website, they put in their SSIS package or anything like that. So that's it. Like we saw, minus all the talking, it took 5 minutes tops for us to build and productionalize a machine learning algorithm using Azure Machine Learning Studio. Definitely want to thank everyone for coming today. I want to thank the PASS organization and the Cloud Virtual User Group for having me. I do have a couple of other talks coming up in this user group. I'm doing another one on Azure Machine Learning Studio, a little bit more advanced. How do we do more than just build a model? How do we optimize models and things like that? Also one about what the role of a data scientist is and how you can become one. Whether you're interested in those talks or any of the other talks here, I highly encourage you to attend these webinars as they're extremely helpful. Other than that, thank you for having me, and there's my contact information, and we can take any questions.
All right. Thank you, Brad. We've got a couple questions here that came up through the session. The first is, do you always need to import data into Azure ML?
Yes. There are ways you can use Ph.D. Insight or even R within SQL to bring your data science to your data, but Azure Machine Learning is the older paradigm of bringing your data to your machine learning.
Okay, and that the next question actually follows up into that one is basically around, I can't import HIPAA regulated data to the cloud. How will this tool help with that?
So there are a couple of things you can do with that. One, I would check about HIPAA. I do know that Azure as a whole is HIPAA compliant, and most Azure resources have guidelines for how to be HIPAA compliant. There's even a federal cloud you can use. So Azure is HIPAA compliant. I'm actually working with a hospital right now. So I would check that. But let's assume you're right. Let's assume you can't get your data into Azure Machine Learning. If you're using one of the other tools, R or Python, what you can do is you can do all of your development locally, and they both have a package or library, as they're called Azure ML, which allows you to take or a Python code that might be built by you or some developers, and you can use the Azure ML web service deployment to just deploy those as an Azure web service. So even if you can't use the studio itself, it still gives you the option of productionalizing via the web services.
All right. And we didn't have any other questions come in while you were answering those two. So at this point, I think we are good for today. Again, I want to thank everyone for coming out. We do have sessions coming up. I am aiming to try to do as many of these as I can find speakers of. If I've got speakers for 3 days a week, I will host these meetings 3 days a week. I've got a very exciting life. So thank you, everyone, and hope to see most of you next time. And thanks, Brad. Thanks a lot.
Thanks, everyone.
Bye.